Good day. Good day to all the students. In this class, we see the Werner theory of coordination compounds. Using that Werner theory, we can solve the book back 1 mark questions, 5 questions. Question number 1, 2, 3, 4 and 16th questions. Also, using the Werner theory concept, evaluate yourself. Question 1. In this class, we see the Werner theory postulates and book back 5 1 mark questions. Self-evaluate, you can try it. Next class we see it. First question number direct question number book back 14th 2 mark. It may be asked in 2 mark or 3 mark or 5 mark. If a 2 mark question means you write down the Werner theory 3 points. 3 mark questions you write down the 4 points. 5 mark question you write down all the points. For understanding purpose, Werner theory I split into the 2 parts because of understanding purpose. First, in Werner theory, first postulates it has a 2 type of valencies. First, primary valency. Second is the secondary valency. These points are used to solve the book back 1 mark question. Therefore, we must understand the concept. Primary valency means nothing but oxidation state of the metal atom. In this, I given the one example. In this coordination complex, central metal ion is Fe. Its oxidation state is +3. Therefore, primary valency of the central metal ion is +3, or oxidation state of the central metal ion is +3. The oxidation number calculation method is, in this case, 3Cl, 1Cl minus 1 charge, 3Cl minus 3, therefore the net charge on the complex ion is +3. In this case, ammonia is a neutral ligand, therefore directly we put the net charge of the coordination complex is +3, that is oxidation state of the metal ion is +3. Secondary valency is coordination number. In this example, coordination number of the complex is 6. That is coordination number determined 2 way. If ammonia is a monodentate ligand, that is one in ammonia donor, that is lone pair donor is N, therefore 6N, that is simply 6 ligands. Monodentate means the coordination number directly this number, therefore 6NH3, therefore coordination number is 6, that is 6 donor atom, that is 6 nitrogen atom coordination number is 6. Otherwise, it has a 6 coordinate covalent bonds. One, two, three, four, five, six. 6 coordinate covalent bonds. Therefore, coordination number is 6. In this example, oxidation state of the central metal ion, that is a primary valency is 3, secondary valency is coordination number, therefore coordination number is 6. Point number 2, the oxidation state of the central metal ion is most of the cases positive, in some cases 0. That is, the positive means the satisfied by the negative ions, that is satisfied by the simple or counter ions. In this example, oxidation state of the central metal ion is +3. This +3 is satisfied by the -3, that is a simple ions satisfy the primary valency -3, that is 1 Cl has a 1 negative charge, 3 Cl has a 3 minus, that is a primary valency is satisfied by the negative ions. So satisfied by the negative ions. In these examples, -3 Cl satisfy the oxidation states. In this example, oxidation state is a +3, that is a positive, satisfied by the negative ions. The negative ions are 3 Cl, that is negative ions. In oxidation number is satisfied by the negative ion or positive ion or neutral molecule. In this example, coordination number is 6. With coordination number is satisfied by the ligand. Satisfied by the ligands. In this example, ligand is ammonia. Therefore, coordination number 6 is satisfied by the 6 ammonia, that is 6 ligand neutral molecule. Therefore, coordination number is satisfied by the ligands. In this example, 6 ammonia. So, the coordination number, the secondary valency is satisfied by the negative ion, positive ions or neutral molecules. The oxidation state is satisfied by the simple ions or ionizable ions. Secondary valency is satisfied by the ligands. Point number 4. Outer sphere is ionization sphere because of outer sphere. In outer sphere, simple ions are available. Therefore, these simple ions are loosely attached, therefore separated in solvent, so it is ionizable. That is outer sphere. This is the inner sphere, these simple ions are in outer sphere. These outer spheres ions are in suitable solvent. It is separated into the ions. Ligands are inner sphere or in coordination sphere. Inner sphere or coordination sphere. Ligands are, that is secondary valency ions, are strongly attached to metal, so not separated, that is not ionizable in solvent. In this example, these ligands are strongly attached by coordinate covalent sigma bond. Therefore, inner spheres are in solvent non-ionizable, but in the outer sphere, simple ions are weakly bonded to the central metal ion, therefore easily ionizable in suitable solvent. Last point number 6. The spatial arrangement of secondary valencies, that is ligands, makes a geometry of the complex. That is, spatial arrangement of this ligand makes the geometry of the complex, so it is a directional property. In this example, these ligands are placed in particular place, therefore makes the shape. The shape of this complex is octahedral. Therefore, these ligands are a directional property. That is, secondary valencies are directional properties. The primary valency, that is, primary valencies are non-directional. That means, in this example, these chloride simple ions are non-directional properties. Now, Werner theory, complex ion. For example, a complex ion color, complex color. In book, this formula is given. Using the data, we can write the coordination complex like this. Group satisfy the secondary valency, that is non-ionizable, inner coordination sphere. Inner coordination sphere, that is 6NH3. That means secondary valency is satisfied by the ligands always in inner sphere. Based on that, we can conclude that 6 NH3s are inner sphere. Therefore, put the 6 ligands in inner sphere. Number of ionizable ions in complex, that is outer coordination sphere, that is it indicates that simple ions. Therefore, 3Cl ions are in outside of the sphere, therefore put in outside of the square bracket, that is simple ions. Next, number of moles of AgCl formed are number of moles of ionizable ions. Based on that concept, based on this concept, book problems are given. In problem only these points are given. From this we solve the question. For example, this is a formula given in book, molecular formula. The number of AgCl formed in this formula 3AgCl. That means 3 Cl ions in outside of the sphere. From that we can write down the structural formula of the coordination complex. 3 Cl's in outer sphere, that is 3 Cl ions are in outside of the sphere. In this formula 3 Cl outside, remaining 6 ligands inside of the sphere. The color of the complex is yellow. Next, second formula is given. The inner sphere inner coordination sphere 5NH3 1Cl, directly put in the inner sphere, 3Cl in outer sphere. Likely 2 Cl's in outside sphere. Based on that we can write down the coordination complex. Third example, this is a molecular formula. It has two forms, trans and cis. Trans has a green color, cis has a violet color. Inner coordination pair has the 4NH3 and 2Cl. Therefore we can write down the complex ion. These ligands are in complex ion in the inner sphere. 1Cl is in outer sphere, that is a simple ions. AgCl molecule is 1, therefore put the 1Cl in outside of the sphere. The limitation of Werner theory does not explain the color and magnetic properties. Werner theory limitation does not explain the color and magnetic properties. This is a direct question number 14. Now solve the book back 1 mark questions. The sum of primary valency and secondary valency of metal M in this complex. M, En means ethylene diamine twice OX oxalate is. To solve this problem, based on the structure of that complex, we already mentioned that primary valency is oxidation number. Oxidation number of this oxidation number of this complex. Oxidation number, in this case first +1 is the net charge on the complex ion, that is Cl has the 1 minus charge, therefore complex ion must have a +1 net charge. Put the net charge. The oxidation state of the central metal ion M we calculate, therefore put X. Ethylene diamine, En means ethylene diamine. This ethylene diamine formula is NH2CH2CH2NH2, that is NH2CH2CH2NH2. This is a ethylene diamine. This ethylene diamine is neutral ligand, therefore totally 2 ligands. Neutral molecule, put the 0. Next, oxalate formula is this is the oxalate formula, that is oxalate formula is COO minus COO minus, that is simply C2H, that is COO minus COO minus C2 CO4 2 minus, that is oxalate has the net charge, ligand oxalate charge is -2, that is C2O4 2 minus. Net charge on the oxalate is -2, therefore one oxalate has the -2 charge. 0, therefore this term will be cancelled. Therefore X -2, this -2 come opposite sides, +2, therefore +1 +2 gives a +3, that is oxidation state of the central metal ion, that is a primary valency is +3. Next point is secondary valency is coordination number. In this case oxalate and ethylene diamine, this is a bidentate ligand, that is it has a 2 donor atoms, therefore this is bidentate ligand, 2 bidentate ligand. Also oxalate is a 1 bidentate ligand, totally 3 bidentate ligands, therefore 3 into 2 6, coordination number is 6. Another way to find out the coordination number, this is a structure of the this complex. Totally 2 ethylene diamine, 1 This is a first ethylene diamine. It has the two donor atom. Therefore, it is bident ligand. Likely another ethylene diamine has a two donor atom. Oxalate also bident ligand, two donor atom, two O. In this case, totally 6 donor atom. Therefore, coordination number is 6. Otherwise, the 6 sigma bonds coordinate covalent sigma bonds. Therefore, coordination number is 6. In question, sum of that is total of the primary and secondary valency is asked. Therefore, primary valency is 3, secondary valency is 6, total is 9. Therefore, the first question, the sum primary valency is 3. Secondary valency, primary valency means oxidation number, secondary valency means coordination number 6. Sum total 9. Second question, an excess of silver nitrate is added to 100 ml of 0.01 m solution of penta aqua chlorido chromium 3 chloride. The number of moles of AgCl precipitated would be. Second question, for in this example, given complex is this. You convert the IUPAC name into the molecular formula format, react with the AgCl, it gives the 2 moles of AgCl. Based on that, we can solve the question. That is 1000 ml of 1m solution of the complex gives 2 moles of AgCl. This 2 moles of AgCl is understand from this equation, 2 moles of AgCl, that is 2 Cl ions are in outside of the sphere. In question, $1000 ml of 1 m complex gives 2 moles. In question asked is 100 ml of 0.01 m solution. First point, from the first point, the 1000 ml of 1 m gives 2 Cl. Therefore, we can change the volume and concentration, that is 100 ml of 0.01. You can solve this. We get the answer of, that is, we can cancel the zeros and multiply. You get the 0.02 divide by 10, 0.002 moles of Cl ions. Therefore, correct option is for a second question is 0.002. Question number 3. A complex has a molecular formula MSO4Cl6H2O. The aqueous solution of it gives white precipitate with barium chloride solution, and no precipitate is obtained when it is treated with silver nitrate solution. If the secondary valency of metal is 6, which of the following correctly represents the complex? In this case, main point, we first note down the molecular formula and secondary valency. From the molecular formula, in this case Cl is in molecular formula, but in B option no Cl, therefore B option will be cancelled. Next, secondary valency of the metal ion is 6. Secondary valency means nothing but a coordination number. In A option, coordination number 4 plus 1 5. Therefore A option is wrong. In D option, coordination number 3 plus 1 4. Therefore cancel out. Remaining one 5, coordination number of the C option 5 plus 1 6. Therefore we can easily solve using these 2 points. That is, first point, no Cl in B option. Therefore, once again I repeat, no Cl. Molecular formula has a Cl, but in B option no Cl. Therefore we can, B option is incorrect, wrong. In A option, using the second point, that is coordination number of, that is secondary valency is 6. That in A option, coordination number is 5. In D option, coordination number is 4. Therefore A option and D option are wrong. Therefore remaining one C, that is coordination number of this 6. Secondly, also we understand for this question, this is for explaining purpose. It may be used for solving the other questions. Second question, explanation once again, molecular formula. In this case, with AgCl, no precipitate, that is Cl ion is inside of the sphere. With the AgNO3, no precipitate, that is Cl ions inside of the coordination sphere. With barium chloride, white precipitate. With the barium chloride, white precipitate. So sulfate is outside of the sphere. Therefore sulfate is outside of the sphere. Also, we understand this point also because of it may be asked in other questions. Sulfate ion with barium chloride makes a barium sulfate precipitate. Likely chloride with the AgNO3, AgCl precipitate. Based on that, this questions solved. Question number 4. Question number 4. Oxidation state of the ion and the charge of the ligand NO in this complex. This is a very interesting example. This complex is formed during the test for nitrate ion, that is brown ring test for a nitrate ion. This is an interesting example. That is why repeatedly this question is asking. This complex ion name is penta-aqua nitrolium ion 1 sulfate. In this case, NO, that is a ligand nitrolium ion, has the +1 charge. Central metal ion oxidation state +1. Therefore, the +1 is calculated from the net charge is +2 equal to, this is a neutral ligand, therefore net charge is plus +2 net charge. Central metal ion oxidation state X, neutral ligand, therefore this term will be cancelled. NO has a +1 charge, only one ligand. You can multiply +1 for find out X. This +1 come this side, therefore come as a -1, +2 -1 equal to +1. That is a oxidation state of the central metal ion is +1. The ligand NO charge is also +1. This complex is formed during brown ring test for nitrate. Now, therefore, the fourth question answer is the oxidation state +1. The charge on the ligand NO also +1. Therefore, D option is correct. Next question. Question number 16. A complex ion which is the oxidation state of the metal is 0. Correct option is this. First complex oxidation state is simply +2. That is a difference between these two. This is for this complex X, net charge is +4. Therefore, +4 equal to central metal ion oxidation state X, totally 6 silicon. Cn has a -1 charge. Therefore, for find out X, this comes this side. Therefore, +6. Net charge is small correction. Net charge is minus 4. That this Cl has a plus 4 for balancing minus 4. Therefore, minus 4 equal to x plus 6 minus this minus 6 come this side. Therefore, plus 6 minus, this is a minus 4. Therefore, minus 4. Therefore, our answer is plus 2. Next, in this case, oxidation state of the central metal ion. Net charge oxidation state of the central metal ion is plus 3. That is but in this case central metal ion oxidation state is 0. In this case, this minus 1 into 3. Central metal ion oxidation state taken as a X. For a B option, the net charge is 0. Therefore, 0 equal to X, that is a oxidation state of the central metal ion. This is a neutral ligand. Therefore, this term will be cancelled. Remaining 3, 1 Cn has a minus 1. Therefore, find out the X equal to plus 3. For this option, oxidation state of the central metal ion is plus 3 likely. For option this case 2, remaining one option, this is has a oxidation state, that is put the net charge is equal to 0. Oxidation state of the central metal ion is X. CO, carbonyl, is a neutral ligand. Therefore, a 0 into 5. This term will be cancelled because of 0. Therefore, X value equal to 0. Therefore, oxidation state of the metal ion complex is 0. Correct option is C. Thank you very much.